All right, welcome back. We are discussing chapter 3, lesson 3 today. We're going to be proving lines are parallel. So to start, we're going to start with this warm-up. What happens with 1, 2, and 3 is you're given 3 conditional statements. And so from these conditional statements, we are going to go ahead and write the converse of each statement. So go ahead and get started. Here's my friend the pause dragon. Remind you to pause your device. When you get done, press play and we'll go over the answers together. All right, see you in a bit. All right, we are back. Let's go ahead and see how you did. So we're going to write the converse. So basically this says if A equals B, then A plus C equals B plus C. So this right here, this is our P, right? And this after the word then, that would be our Q. And so remember the converse is Q to P, right? The conditional is P to Q. That's what this is. P is first and then Q. And the converse is Q to P. So, we're going to be dealing with a lot of converses today in our lesson, so we're just kind of re-familiarizing ourselves and reviewing that idea. So Q to P, so your answer would just be if A plus C equals B plus C, then, oh, that's not, what was that? Then A equals B. All right, so if you get that one right, great job. Let's move on to the next one, see how you did. This right here, this after the word if, so if measure of angle A plus the measure of angle B equals 90, then angle A and angle B are complementary. So this would be the P, and then after the word then would be, this would all be the Q. So we'll just go ahead and write it. If angle A and angle B, we're writing the Q first for the converse, are complementary, then and now we write the P, measure of angle A plus measure of angle B equals 90 degrees. So if you got that one right, awesome, awesome. On to the last, if AB plus BC equals AC, then AB and C are collinear. So after the word if, that's always our hypothesis, and after the word then is our Q, and then we have to do the converse, which is Q to P. So we're just going to write it. So if Q, A, B, and C are collinear, then AB plus BC equals AC. So if you got all 3 right, awesome job. So we are moving on and we're talking, like I said, about a lot of converses, Q to B. And really this lesson is kind of the converse of the last lesson, chapter 3, 2. And remember in chapter 3, 2, we had, the start of it was that we had 2 lines that were parallel. So we knew that 2 lines were parallel. Right? That was the first thing. So if 2 lines are parallel, then we could apply 4 different things. We could apply A, which was the, what was it? It was the corresponding angles postulate. We could apply the alternate exterior angles theorem. We could apply the alternate interior angles theorem. And lastly, we could apply the same side interior angles theorem. But it was all based that these 2 lines are parallel. So today we're doing the converse, right? We are going to be using these to prove lines are parallel. So we're going to start with this, and then if this is the case and we have 2 angles that are congruent, then we know that the 2 lines are parallel. So for the first one, we start here with the converse of the corresponding angles postulate. And what this states is if two coplanar lines are cut by a transversal, right? So we have coplanar lines. These are two lines that are in the same plane. Now, it doesn't tell us that they're parallel. It just says, hey, if you have any two lines and they're in the same plane and they're cut by a transversal, here's our transversal here, so that a pair of corresponding angles are congruent, then the two lines are parallel. So we can say that M and N are parallel. So that's kind of cool, right? So you have two lines. We don't know anything about them, but they're cut by a transversal. And let's just say, hey, if this is 120 degrees and this is 120 degrees, which mean they're the same, and these are corresponding angles, right? By the converse of the corresponding angles postulate, we actually end up knowing that we can prove that M and N are parallel. So that's kind of like the grand finale of the whole thing, is proving that the lines were parallel. So remember, in the last section, we started with the lines parallel, but this one, in this section, we're going to be using all of these things, and then the grand finale will be to say that the lines are parallel. So it's the converse, right? So let's go ahead and look and see how this, look at some examples. So let's start with example 1. So example 1 says, using the converse of the corresponding angles postulate. Okay, use the converse of the corresponding angles postulate and the given information to show that L is parallel to M. So we're trying to prove that. All right, here's L and here's M. Here's our lovely transversal and all the angles that it creates. So this is, I don't know, I just like it. So this is what they're giving us. They're giving us that angle 4 and angle 8 are congruent. All right. So we have these two angles right here. So I'm just going to go ahead and write down that given information. So angle 4 is congruent to angle 8, and that is given. And it's just pretty simple. What type of angles are these? Well, they're on the same side of that transversal. And remember, L, this is on the bottom of L, and this 8 is on the bottom of M. So when they're on the same side of the transversal and the same side of these lines, we know that they're corresponding angles. So if they are the same and they're congruent, then by the converse of the corresponding angles postulate, we know that these lines are parallel. So we can just say L is parallel to M by the wonderful, magnificent converse of the corresponding angles postulate. Boom, that's it. A two-step proof. Pretty nice, nice. Okay, let's look at the next one. So this one example is going to actually involve some of our algebra skills. So let's look at it. It says, use the converse of the corresponding angles postulate and the given information to show that L is parallel to M, okay? So remember, to show that L is parallel to M, we have to show that we have two corresponding angles and they are equal to each other. And if we do that, then we can say that those two lines are parallel. So they give us this information right here. They say the measure of angle 3 is 4x minus 80, and the measure of angle 7 is 3x minus 50, and then they tell us what x is. So let's just go ahead and look at those angles and see if we end up having corresponding angles. So that's 3 and that's 7. So are those corresponding angles? The answer is yes. They're on the same side of the transversal. This is our transversal. They're on the left side. And this side L, it's on the bottom of line L. And this 7 is on the bottom of line M. So these are corresponding angles. So if we can just prove that these are equal to each other, then we know that those two lines are parallel. So let's go for it. The first thing we have to do is write down all of this given information. So here we go. Measure of angle 3 equals 4x minus 80, and the measure of angle 7 equals 3x minus 50, and we know that x, well, we'll just say it here, x is equal to 30. Okay, and this is all just given information. So from here, we just really substitute x in and then see what we end up with. So measure of angle 3 is equal to 4 times 30 minus 80. And I'm going to do measure of angle 7 at the same time. 3 times 30 minus 50. And that's just substitution. Need the parenthesis there. And we'll just do one thing at a time. So we'll do the multiplication. Measure of angle 3 equals 4 times 30. I always like to just go 4 times 3 is 12 and add a 0, so I know it's 120. Minus 80. And then the same thing here. 3 times 3 is 90. Add a 0. Oh, no. 3 times 3 is 9. Add a 0 is 90. Sorry. So the equals 90 minus 50. And that's, we're just simplifying. And then we're just going to simplify one more time and just do this. And we end up with the measure of angle 3 equals 40. And the measure of angle 7 equals 90 minus 50, which is also 40. So we just simplified again. Don't get thrown off by these numbers. So just don't worry about the numbers and all that type of stuff. Just continue to work down. Okay, so they're equal to the same number, which is great. So we just have to show that the measure of angle 3 is equal to the measure of angle 7. So we're going to do that by substituting. Measure of angle 7 is the same thing as 40, so I'm going to substitute that in here. And so I end up with measure of angle 3 equals measure of angle 7. That's substitution. Okay, and then I'm just going to keep going. I think for this, you have to show that, I'm going back to the Converse, that these are congruent. So we need to have it in that congruence form. Also, I forgot to say, this is a flashcard. Okay, so please make sure that you make a flashcard for this and that you're reviewing all of your flashcards, because the more you review, the more that you commit these to memory, the easier everything gets. Okay. So yeah, so we have to change this to the congruent. So I'm just going to make a number 6 here. And then, you know, angle 3 is congruent to angle 7 by the definition of congruent angles. And then now that we have stated that 3 and 7 are congruent, we can actually say that those two lines are parallel. I'm going to actually just give myself a space. So L is parallel to M by the converse of the corresponding angles theorem. All right, perfect. So let's go on to the next one. So check it out, example 1A. So for this one, I actually want you to try to do this one on your own. So here's my friend the pause dragon, reminding you that now it is time to go ahead and try to figure this one out on your own. When you get done, press play and we'll go over it together. All right, see you in a bit. All right, we're back. Let's see how you did. So it says, use the converse of the corresponding angles postulate and the given information to show that L is parallel to M. Okay, perfect. So what do we have here? Measure of angle 1 equals measure of angle 3. I just want to see if these are corresponding angles. So here we have 1, and yes, we have 3, and yes, we have corresponding angles. So if we can show that those two are the same, then we can show that line L and M. Okay, so this, I hope that, this is supposed to be N and M. Okay, so just erase that. N is parallel to M. Okay, we have to show that those two are parallel. Okay, okay, so we're given this. The measure of angle 1 is equal to the measure of angle 3. So that is given information. now to prove that they're parallel, we have to change this format. Okay, so I'm going to go ahead and change that. So if you didn't do that, go ahead and make like a 1.5 step or something right here. You want your notes to look the same as mine, or just erase. So we can change the format by the definition of congruent angles. And then we can just make a 3 below here. And we can say that those two are congruent, so that means that N is parallel to M by the converse of corresponding angles postulate. Okay, so that's my abbreviation for that. All right, great. If you got all those right, awesome, awesome. If not, go ahead and erase and change so that your notes look the same as mine. All right, so we're going to go on to check it out example 1b, and this says use the figure above to show that L is parallel to M. Okay, so there is an error. This is actually N is parallel to M, so I'm just going to erase this and write N is parallel to M. And now we're talking about the measure of angle. So we're going to use this figure. We're looking at the measure of angle 7, which is this one right here, and the measure of angle 5, which is this one right here. So the question is, okay, are these corresponding angles? And yes, so if we prove that those are congruent, then we know that we can show that these two lines, N and M, are parallel by the converse of the corresponding angles postulate. So I want you to go ahead and try this one on your own. If you need help, go ahead and refer back to that example 1b that we just did together as a guide. If not, try to do it as much on your own as you can. What was the other thing I was going to say? Yes, oh yeah. So here's the given information. The measure of angle 7 equals 4x plus 25. The measure of angle 5 equals 5x plus 12. And they give us that x equals 13. So go for it. You can do it. Here's my friend the pause dragon. Remind you to pause your device. Go ahead and try to prove that N is parallel to M. And then when you get done, press play and we'll go over it. All right, let's see how you did. First, I'm going to go ahead and write down all this given information. And then right here, so that's given. And then I'm just going to start substituting this in. All right, so measure of angle 7 equals 4 times 13 plus 25. Measure angle 5 equals 5 times 13 plus 12. All right, that's just substitution. I'm actually going to make a 2.5 here because I think there's a chance I could run out of room. So I'm going to make a 2.5 and a 2.5 here. And okay, so 4 times 13, so measure of angle 7, got to do this multiplication. What's that? 12, carry the 1, 52 plus 25. And then 5 times 13 would be 15, carry the 1. I think that's 65. So measure of angle 5 equals 65 plus 12. So we just simplified there. And then we add these two things together and we get the measure of angle 7 equals what, 77? And then here, measure of angle 5, 65 plus 12, I think that's 77 as well. So boom, they're the same. That's awesome. So we can say, we can just, substitute, since measure of angle 5 is the same thing, we can substitute that in for 77. So we have measure of angle 7 equals measure of angle 5 because of substitution. And then to prove those lines parallel, we need this to be in the congruence form. So I'm just going to go ahead and change that. Definition of congruent angles. And then lastly, these two angles are congruent, 5 and 7. So therefore, we can say that those two lines are parallel by the wonderful, magnificent, I'll just do it right here. So what is this? N is parallel to M by the converse of the corresponding angles postulate. All right, so if you got all of that right, wonderful job, very impressive. Okay, before we go, let's go ahead and talk about this postulate. It's called the parallel postulate. It basically says through a point P, not on line L, there's exactly one line parallel to L. So what this means is we have a line, and this is line L, and through a point that's not on this line, so let's call this point P. Basically, it's just saying that there is only one line that can go through this point that is parallel to line L. There's only one line. Like, there can't be any other line that goes through P because it wouldn't be parallel, right? So there's only one line that can go through P that is parallel to L. There's only one possibility, and that's called the parallel postulate. So they'll use this in a proof, I think in this chapter or the next. Okay, so just that particular concept. So just know that's the parallel postulate. This is a flashcard. This one isn't like as popular as let's say vertical angles theorem or the linear pair theorem, or, you know, all the ones that we're doing right now. You'll use those ones a lot, like corresponding angles postulate, alternate exterior angles theorem, alternate interior angles theorem, same side interior angles, and then all the converses of those. You're going to use those ones a lot. This one is not as popular, but I still wanted to go over it so that you understand the concept. So, all right, that's it for example 1. We will see you in a little bit for example 2. All right, great job.